Hello. So this is covering radical substitution through mechanisms of initiation, propagation, and termination, at least for the main portion of the question. On part B, part A is just to first ask which is going to be optically active and optically inactive. It has been a little bit since I have been in organic chemistry, but there are certain things that I remember sticking out to me and uh, that can hint to you whether something is active or inactive. One thing it should be noticed, I have two black boxes. I could have made this a little more ambiguous and covered over one box with the other, but there are two drawings underneath there, but it's only one name. So we will discover what's going on with that in a second. And there's only one drawing for the 1,4-dichloro-2-methylbutane because there's only that drawing. You literally draw it that way and it takes that form. The thing to note with 1,4-dichloro-2-methylbutane is it is very easily able to spin about the axis that cuts through it this direction. There's even pretty easy rotation to go about it, the axis that goes through that direction. And I guess technically it basically has all three axes of rotation freedom, and there's not stereochemical restrictions on certain things because those chlorines aren't butting up next to each other. Now, 1,2-dichloro-2-methylbutane has some other funky business going on with it. In that, since the chlorine and the methyl are sharing that second carbon group, technically, I believe the term is stereoisomers. I could be wrong. It's basically saying that there's different stereochemistry, that you'll still have the parent carbon chain, the butane chain, but that methyl group can either be optically backwards, or not optically, spatially backwards, meaning it's kind of like back into the page and the chlorine's coming out at us, or the chlorine atom in the bond is doing what the other one used to do and coming out. I forget which one is R and which one's S configuration. There's ways to determine that. I am at a loss for remembering which one that is right now, but it is going to be predicted that the 1,2-dichloro-2-methylbutane is inactive because there's some stereochemical things going on that if you do any rotations, you don't get sort of like a mirrored image back. You will end up getting something that looks different whenever you spin that around the other way. You won't be able to get the mimicked thing back. You'll quote unquote transform it into the other one, and it's not active. You'd like test-wise, there'd be things that you could do to say, oh, this one's not active. There's not going to be a lot of radiation that can make it excited to do things, where 1,4-dichloro in a test with light radiation would probably go nuts. Now, to provide stepwise mechanisms using initiation, propagation, termination. I meant to box these so you didn't instantly get them right away. I forgot. Oops. So there'd be initiation of the chlorine atom breaking up into its two radicals. Initiation, you almost always start with no radicals. I haven't really seen any that start with radicals over here. Usually it's everything's neutral, goes to everything radical. In initiation, propagation, if you had one radical to start with, you'll have one radical to end with. You won't go up in radicals, you won't go down in radicals in a propagation step. And termination, name implies, all radicals go away. If you have a whole bunch of radicals on this side, you'll terminate them all, come to the end. So this is to create the 1,4-dichloro-2-methylbutane. So those two are apart into their specifics. This bond, one electron will move here, one electron from the chlorine from the radical will move there to create a new bond and take that off as HCl, and the other electron is left to go to the carbon and create that carbon radical. The other chlorine that got ripped off and has a radical comes in the termination step and creates the bond and creates the 1,4-dichloro 1,4-dichloro-2-methylbutane. Again, I meant to box these, but to no surprise, the same initiation step is shared throughout this whole problem altogether. And the other common shared process is that this image is badly drawn. Those electron movements are supposed to be up top for the HCl. I'm sorry, I drew that very bad. I had seen the mirroring effect, but forgot to mirror those arrows, those electron arrows up to there. So the hydrogen bond there between the carbon and hydrogen is to break. One goes there, chlorine gives one, the other leftover goes to the carbon, creating the carbon radical. And then termination to create the carbon-chlorine bond there. So those diagrams are badly drawn. I'm sorry about that. But then still the same idea happens. You break the bond, one goes to carbon, one goes to make the bond with the chlorine, and you leave with hydrochloric acid. Same thing happens in this reaction as well, just very badly drawn arrows. I'm so sorry. And then termination happens, and you get this configuration of 1,2-dichloro-2-methylbutane. And this is the other configuration result of 1,2-dichloro-2-methylbutane. I hope this helps. I'm sorry that this is a couple days late. I've had some family life going on. If you have any further questions, message in the comments or message me on the site. Thank you. I hope you have a good night.